you for joining us today. Great. Hello. Welcome to everyone to today's webinar, Mind Beyond Operations, part of our Mining Innovation Lifecycle series. My name is Tammy Beal, and I am the Austmine Membership Manager for Queensland, and it is my pleasure to be your host today. Before we begin, I would like to acknowledge that I am hosting this webinar from the traditional lands of the Yagara and Turrbal people. And we acknowledge that the traditional custodians, the various lands on which we meet today, and recognize all the Aboriginal and Torres Strait Islander people attending this webinar. As the mining sector is undergoing a significant transformation driven by automation, digital systems, AI, and sustainability, this six-part webinar series has been driving the central conversations affected by the mining lifecycle. And this session will showcase the latest technology for cost-effective rehabilitation, circular economy opportunities, and the future of post-mining land use. The format for today's webinar consists of presentations from 4 Austmine member companies, and it will be followed by a live Q&A. If you have questions for any of the presenters throughout their presentations this afternoon, you can type your questions into the Q&A interface at the bottom of your screen. And if you have a question that's directed towards a specific presenter, then certainly add that to your question. And I should also note that this webinar is being recorded and will be available for on-demand viewing and for you, of course, to share with your colleagues. All right, so let me introduce today's speakers. Joining us, we have 4 representatives from leading Austmine member companies who will share their latest innovations, insights, and real-world applications. Today's presenters are Bianca Vague Howe, Environmental Approvals Practitioner with Aurecon, and Bianca will be joined by Dr. Isha Ahmed, Geoscientist from Regeneration. We'll also have Nick Barros, Mine Sustainability Lead with AMC Consultants, Sam Duncan, the CEO of GXLab, and finally, Jonathan Melm, Group Manager, Thiess Rehabilitation. All right, well, that concludes today's welcome and introductions. So without further ado, I would like to hand it over to our first presenter, Bianca with Aurecon. Bianca, over to you.
Thank you, Tammy, and welcome everyone. Good afternoon, good morning from wherever you are in the world. My name is Bianca Vogtshaug. As Tammy said, I'm from Aurecon and presenting with Dr. Aisha today from Regeneration. So what we want to talk to you about today is how can you ensure effective planning to help optimize your post-mining land uses? And we'll run through this at a high level before moving into the regeneration slides, which go into that in further depth as one example. So what is a post-mining land use? Most people today will know very well what a post-mining land use is. Whoops, skipped ahead there. But there's different terminology across different Australian jurisdictions, but really at the crux of it, it's a designated purpose or activity for land after your mining operations cease. And we really look to find some purposeful rehabilitation and conversion of your sites to what most jurisdictions consider safe, stable, and productive areas, or have some similar terminology to that effect. But why is it important to know your post-mining land use or uses across your site? Well, as we just kind of hinted at, it's required often by legislation. It's recommended by best practice closure frameworks like ICMM. It underpins your social license and it helps engage with future landholders and stakeholders and speaking to your post-closure outcomes. But really, when we're talking about optimization, it helps you effectively plan for your closure, including things such as targeted trials and meaningful progressive rehab, which can also feed into how you plan for your rehabilitation liability at the end of the day. There are many different types of post-mining land uses, but in our practice, what we've seen is some real common themes come across about the types of uses that are approved. We see generally a large amount of approvals for grazing, water management, such as water storage and voids, and native ecosystem. And where that comes from, we've noticed, is usually a reliance on the pre-mining landscapes and assumptions around what you can return it to because it was there pre-mine. But interestingly, we're starting to see some real novel uses creep in, and that's probably what's the most exciting thing that we want to talk to you about today, and where you can move and optimize to. And what we want to hit home on today is that you don't have to stick with your post-mining land use once you've been approved for it. There is always room to optimize, change, and look at novel post-mining land uses, which are slowly being accepted by the regulator. You can see here in this pie chart in Queensland, this is an example of the different types we're starting to see and the huge predominance there in grazing and agriculture. But you can start to see a small slither in the pie chart being these more novel recreational, special purpose, industrial uses that are starting to be approved. But really, how do you unlock and optimize your post-mining land use? Thinking about that, we've across our practice seen about 4 common themes and elements, and noting it's a really iterative process as you go through. But what's most important is you need to start this process early, make strong key decisions, and prepare to adapt and change as you move forward. And what we find is that adaptation is often ignored, but it is the most important part to optimization. And as I've said before, you can change your post-mining land use or uses at any point, and there may be more rigorous jurisdictional requirements depending on what change you're trying to look at, but there is possibility and there is precedence to support change. So step 1, we usually look at exploring, so mapping out your assets, making sure you understand your land capability, your potential uses, building your knowledge base. And importantly, as you move closer to closure, your map and your information and knowledge base should progress and become more informed. Step 2 is looking at engaging. So identify all your stakeholders, engage early and often. One of the things that we've seen a lot is stakeholder expectations, including regulatory bodies. They change, and mines often last, or their mine lives span decades, not including closure and post-closure monitoring, which take even longer. So make sure you keep that engagement updated and you understand the potential post-mining land uses that engagement may put forward. And there are some real novel engagement methods that we're starting to see, including things such as co-design processes, where you work hand in hand with community and stakeholders to actually co-design your post-mining land use. And of course, step 2 is important, which is engage with your regulatory bodies to support that approval of your post-mining land use. Step 3 is once you have your ideas and your options, put forward all your options and be open to your novel, innovative options. Have a clear, consistent ranking, like we've got an example on the screen. Run through that ranking with the right stakeholders in the room and knowledge base. But really what we're finding is don't discount your novel options due to regulatory changes, because there has been a mass amount of policy involvement around post-closure mining and land uses. So there is opportunity to move to some of these novel outcomes. And number 4, adapt. So this is a really key part of optimization. So to ensure your effective planning and decision making is optimized, make sure you're flexible, make sure you understand your stakeholder expectations, your regulatory approaches, knowledge base and technology, and be prepared that they will change and evolve. And one of the things that we're doing a lot with our clients is making sure they understand their contingency options, they research them appropriately, and they have them there ready. So if you've got a post-mining land use option that you're taking forward, make sure you have your contingency options explored to an appropriate degree as well. And on the page here, you can see kind of that process of adaptation. So planning, trialing, progressively rehabilitate if you can, monitor, remediate, but be prepared to restart that process at any point if you need that flexibility to look into your novel contingency options, and most importantly, engage across that life cycle. And so now I'll hand over to Aisha from Regeneration, who will kind of dig into one of the ways to optimize your post-mining land uses that Regeneration is working on right now.
Great. Thanks very much, Bianca. So yes, as Bianca indicated, over the next few minutes, I'll walk you through the Headley case study. So we'll talk about how reprocessing mine waste can serve as a kind of bridge between extraction and restoration. So using the recovered value from reprocessing of the mine waste to fund the cleanup, and then being supported by new technologies that make this approach both economically and environmentally viable. So just next, please. There should be an animation. So this is, oh, just one back. just so you can see the hole. But this is Headley, so it's a gold cobalt legacy site. It's about 3 hours east of Vancouver, Canada, and Vancouver is where I'm based. So on the left of the slide, you can see the Similkameen River. And then in the middle of the slide, there's a highway running through the center, and that highway leads into the town of Headley, just out of this frame. So between the road and the river sits about 1.5 million tons of unlined, uncovered tailings. And that tailings contains gold, arsenic, and cobalt. And of course, some of those metals are slowly leaching into the river. Next, please. So gold mining in this area, it began in the late 1800s and it continued into the 20th century. And actually back in the 1980s, an operator actually attempted cyanide heap leach reprocessing. But unfortunately, this actually created additional negative impacts instead of generating any value. So limited reclamation followed by this operator, but after that company went bankrupt, the site was reverted back to the provincial government as an abandoned mine. And this story is very common, not only in Canada, but around the world. So this is where regeneration became involved. Next slide, please. So this project, Headley, it's a direct partnership between the provincial government and regeneration, but it's done in very close collaboration with the Upper Similkameen Indian Band. And we all know that projects like this really rely on strong collaboration and engagement. So from day one, on the Headley project, we brought Indigenous rights holders, the British Columbia provincial government, regeneration, all of our technical partners, our engineering teams together. And that partnership has continued through the pre-feasibility process I'll describe, with ongoing coordination of meetings, but also in-field visits, as you can see on the right, just to really maintain trust and alignment on where the project is going. Next slide, please. So back in March of last year, we completed a sonic drill program on the tailings at Headley. And Drill Core went through, the full geochemical, environmental, mineralogical, metallurgical test work that's typical of exploration and early stage mining projects. And the goal of this test work was not just to quantify the amount of gold and cobalt available for reprocessing, but really to understand how these and other elements occurred. So the mineral hosts, the particle size, and really could the material be recovered. So just to provide a sense of scale on these projects, this initial drilling and geochemical work, it cost about $400,000. It took about 3 months to do, from planning to completion. And then the follow-on test work, that pre-feasibility flow sheet development, engineering design, it's added about another $750,000 and nearly a year. So it's really just a reminder that meaningful site evaluation for reprocessing in specific, it requires time, it requires resources, and an upfront investment before a project is actually confirmed as feasible. Next slide, please. So using all the information collected from the drill program, we built a 3D geological model of the tailings. This is a non-compliant contained metal estimate, I must stress that, but we're looking at around 1.5 million tons at a gram per ton gold, yielding about 40,000 ounces of gold. Next slide, please. So all this work really led to the development of this pre-feasibility flow sheet, and we'll continue to optimize this as we move into feasibility. So I'll just walk you through quickly. The tailings are first excavated. They're then delivered to a repulp sump via a mobile feed hopper. They're then pushed through a high-pressure slurry ablation accelerator to clean and disaggregate the material. This material then passes through a gravity circuit, a leaching circuit, and then a typical solvent extraction and electrowinning circuit. The resulting leach solution is then which is enriched in gold and cobalt, is processed through that SEEX workflow, and then we generate secondary tailings, which are now non-acid generating, and those are filtered to produce near-dry stackable cakes, which are engineered into stable landforms. And just advance one, and you'll see a red box show up here. And, at regeneration, we really understand that waste streams typically cannot be processed using conventional methods. We need an innovative approach. And that innovation really comes in the high pressure slurry ablation and tank leach system, where we're using non-cyanide leach alternatives, which are actually generating better recoveries than conventional cyanide. Next slide, please. So the final land use vision here will be led by the Upper Similkameen Indian Band, but the possibilities are wide ranging. So just advance there, please. What they're thinking of is recreation sites with walking trails, fishing, access to camping, all for the local community and the broader community. Next slide, please. So before wrapping up, I just wanted to mention one more project very quickly, this time a little closer to home for those in Australia. So this is the Mount Oxide project in Queensland. We're partnering with the Queensland government, who holds the legacy liability of this site, as well as with True North Copper, who is the exploration permit holder. And we're looking to assess the recommercialization potential of the historic mine waste. So we've secured over $500,000 in grant funding from the government. We're completing a sonic drill program and baseline metallurgical test work. And in fact, I'm heading to Queensland tomorrow to kick off this drill program. Last slide, please. So just some final thoughts, and very aligned with the theme of this webinar. We know that reclaimed mine sites can support a variety of future land uses. Waste reprocessing for restoration is one of these land uses, perhaps an interim land use, but it really demands innovation across the mining value chain, and its success will be based on the collaboration of industry, of technology partners, of government, and communities. So thank you very much.
All right, great. Thank you so much, Bianca and Aisha. It was a fantastic presentation with great case study in there. I would now like to introduce you to our next presenter. It's going to be Nick Barretts, the Mine Sustainability Lead with AMC Consultants. Nick, over to you. Nick, I think you might be on mute.
I am. Sorry. I'll go again. So hi, everyone, and thanks for joining us. I am Nicolau Barros, Mine Sustainability Lead at AMC Consultants, and today I'll be taking you through a narrative that brings together three of our ESG-focused major streams of work and experience from recent past. That is strategy optimization in open pit to underground transitioning, resilient open pit mine planning, and holistic mine planning integration principles, all of which are backed by our experience working with our clients. And what unifies these is a straightforward idea that ESG constraints are no longer downstream adjustments. They are first order design inputs that materially reshape what an optimal mine looks like. So why integrate early? Sorry, there's a bit of a delay. Yeah. Why integrate early? The mining sector has endured profound transformation driven by automation, digital systems, AI, and sustainability imperatives. And this is not new, neither it is a passing trend. These forces shape every phase of the mining lifecycle, from exploration through operations, and ultimately closure through to relinquishment or transition to other desired post-mining land uses. As highlighted in this webinar series and following from my colleague's presentation, we're no longer simply extracting minerals. We're increasingly designing mines in ways that minimize disruption, reduce long-term liabilities, and provide future-ready post-mining land use pathways. Sustainability is often seen as a result of strategic choices. However, our experience and case studies show that waiting to assess emissions, water use, or disturbance until after optimization leaves enormous value on the table and weakens resilience. To illustrate, the photo on this slide is called Bustling Boddington and was taken by an astronaut on September 2024. It depicts the small town of Boddington here in WA, which is surrounded by two very different types of mining, for gold and for bauxite. And these are very different in that they are designed, operated, and closed under very different criteria and for different objectives, leaving very different challenges behind. So mine planning as the ESG lever. Across our experience and other evidence by the industry, the message is consistent. Holistic mine design and production scheduling optimization directly influence environmental, social, and governance outcomes. This makes mine planning a sustainability lever, a risk management tool, and a strategic enabler for cost-effective closure or transition to post-mining land uses. Building resilience requires turning ESG themes into variables that mining organizations can control. These include environmental levers like diesel intensity, electricity intensity, water abstraction, and disturbed areas, social permitting and approval levers like disturbance ceilings, visual, dust, and noise envelopes, progressive rehabilitation expectations, and non-environmental and social sensitivities, and governance levers like emissions baselines, disclosure thresholds, and financial assurances and closure provisions. Through integrated planning, existing and new projects can uncover major sustainability benefits, including minimizing disturbance footprints, like adopting ESG-driven strategy optimization for the choice of mine method, minimizing societal disruption, like considering community engagement input into design, not just FPIC, reducing greenhouse gas emissions through optimized material movement and method selection, promoting better and greater utilization of natural resources by aligning extraction method, timing, and processing pathways with ESG-aligned design objectives, and reducing closure scope, cost, and financial liability through early visibility of end-state landforms and rehabilitation needs. And these are deep project shaping levers, not afterthoughts. So the role of trade-off analysis. So trade-off analysis incorporating ESG factors is critical. This analysis often reframes the decision space as in, for example, open pit mining may have higher potential impacts like disturbance, emissions, and footprint, and underground mining may reduce these impacts and improve long-term closure efficiency. Even if the preferred method remains open pit, the study process reviews preventative and mitigating controls that enables optionality that materially improve ESG outcomes. Strategy optimization, particularly AMC's Hill of Value approach, which was tested with open pit to underground transitions and emissions strategies, evaluates the mining system holistically. It helps generate trade-off fronts, not just single solutions, and reviews the real cost of ESG compliance versus unconstrained MPV maximization. Its core design elements include, although not limited to, scenario design with climate beams, hydrologic regimes, energy price paths, regulatory environment tightening, and decision variables of open pit geometry, or I should say pit geometry, depressurization, energy portfolio, cutoff grades, integrated waste routing, which then culminate with the different outputs of NPV, cash flow robustness, movement intensity, energy and/or water intensity, and disturbed area evolution. Critically incorporating ESG trade-offs early enables intelligent, well-quantified decision-making rather than retrofitting mitigation once impacts are already baked in. And stakeholders and social guardrails as design inputs. So stakeholder engagement and impact assessments must be integrated early into planning, not appended at the end. Done well, this transforms issues and opportunities identification, approvals pathways, social acceptance, and long-term relinquishment or post-mine land use success. Even if ESG factors may translate into intangible optimization parameters, they can be assimilated as policy decisions and act as unchangeable decision boundaries aligned with sustainability goals. Non-physical or hard-to-measure aspects should still influence decision-making within the optimization framework. For instance, social dynamics affecting project success, such as when cultural values restrict water and land use. Stakeholder-derived risks and expectations become design and scheduling inputs, not constraints discovered too late to influence this strategy. And progressive rehabilitation and tactical integration is perhaps one of the most obvious of the key themes is the need to integrate rehabilitation into both strategic and tactical planning. And that includes scoping stage definition of progressive rehab opportunities, integrating planning, scheduling, and execution activities into brownfield expansions, operational alignment of landform development, and early recognition of closure material requirements. When done correctly, mining progressively builds towards its closure criteria aligned final landform, which reduces closure scope and cost while improving environmental outcomes. And evidence, governance, and financial liability. So a final point is that the accurate first principles financial liability assessments are a cornerstone of responsible mine planning. These assessments enable appropriate provisioning, predictable end-of-life transitions, transparent governance, and credible commitment to rehabilitation and relinquishment. Mine planning directly influences these liabilities by determining the scale of disturbance, the timing of rehabilitation, and the complexity of the landform. And in closing, sustainability outcomes are not produced at the end of a mine's life. They are designed from the beginning. The integration of ESG factors into mine planning and scheduling, supported by robust trade-offs, stakeholder engagement, and progressive rehabilitation and financial governance, creates pathways to lower impact and risk and enable more successful closure and post-mining land use transition. I guess that's it for now. So thank you for your time, and I look forward to your questions.
Awesome, great. Thank you, Nick, for that insightful presentation and a great lead in to my reminder that if you do have questions, please feel free to use the Q&A interface at the bottom of your screen to submit them at any time during the presentation. All right, let's get on to our next presenter, who is going to be Sam Duncan, the CEO of GXLab. Sam, over to you.
Thanks, Tammy, and thanks everyone. Great to be here. Just a little bit about us, I guess. We are primarily a technology company. We're not a service provider like some of those, many of the others here. We provide technology for environmental measurement, both hardware through a mid-infrared sensor, as well as software to help with data management, mapping of soil, and modeling. We have an interesting history. We started life in 2018, primarily in agriculture, so helping with agricultural soil sampling and soil testing, and commercializing some digital soil mapping technology out of the University of Sydney. Last year, we acquired a company called Ziltech. So I'm sure some of you around here have heard of Ziltech. They provide a mid-infrared spectrometer. If you haven't heard of Ziltech, you might have heard of REMscan. So REMscan is this mid-infrared spectrometer that does primarily TPH measurement. Past 12 months, really, we've been fusing the two technologies together to provide a really powerful tool for contamination testing across mining, oil and gas, and agriculture. And we still do a lot of agricultural soil sampling, by the way. Some of the challenges that we see across our client base, particularly here in Australia, I think I probably don't need to repeat these. These were summed up quite nicely by CRC Time. And we'll talk about why these are how these sort of flow through and impact mine closures. But leadership is a huge one. But really, I see sort of the first three connected. So connecting the operations and closure phase, business case for asset transfer. Look, they all come down to this part of the root challenge for mine closures is that they're not considered early on in the mining project. They're considered as a separate thing. We stop here and then we enter the closure phase. And what I'll talk through today is, I guess, some of the procedures, some of the frameworks and some of the systems that we're helping and providing our clients with to help remediate that and help reduce the overall cost of mine closures into the future. So just wait for this to catch up. So some of the big cost contributors, and this will be very focused on cost because we are a very cost-efficient technology in helping our clients reduce costs very simply. First and foremost, the delineation of contaminated areas. So when you have a mine closure, understanding where the contamination lies and the risk there. And there was some earlier presentations which I think summed that up really well. So I won't hark on too much about that. The difficulty of separating high liability and risk material, same thing. The third is one of the more important ones, which is data continuity between field teams, consultants, labs, and owners. And that is through the life of the mine, not just at the closure phase. And there's some really obvious ones here around, particularly if contamination is detected early on, immediately after the contamination. Well, you immediately have a spatial understanding as to where that contamination occurred, if not a really accurate picture. So you're able to then save money come mine closure and having to identify that. And all of this sort of compounds and limits the ability to demonstrate progress. At the end of the day, most of what our clients are after is governance and compliance when it comes to mine closure for government regulations. And we've had a really strong background, I think, particularly in agriculture. About 30% of Australia's clean energy regulator soil carbon projects are run through our platform today because of that ongoing compliance need for measurement, in particular soil measurement as well. So the workflow. So I'm going to spend about 30 seconds on this workflow. It's really critical. It sort of outlines how we developed our plan, sample, analyze, report workflow, which is a bastardization of the OODA loop framework. So if you've heard of OODA loop, Observe, Orient, Decide, Act, it's a framework that was developed in the 1950s as part of the Korean War as a way for the US Air Force fighter pilots to combat the superior MiG aircraft at the time that the North Koreans and the Russians and the Chinese were flying. So really interesting. I like it because I'm ex-Air Force myself. So I love introducing military frameworks into these things, and environmental measurement's no different. So how does this relate to environmental measurement? Well, we tend to do a little bit of observation up front. So observation is really crucial, and particularly understanding where to collect samples from, where we need to manage. It's pretty simple and straightforward. Orient yourself in relation to the policy, in relation to the governance, in relation to what it is, what data you need to collect and measure in field. And that really helps design a sample plan. Decide is once you have that data and once you understand what's happening under the ground, in our case, you can start to make decisions around what to do next, and then, of course, act on those decisions. So remediate in the context of soil remediation and contamination. But then we loop back, and that loop is probably the most important thing. And I'll talk about that in a second, and how we reinforce that OODA loop cycle, in particular the cycle through ongoing measurement and reducing the cost of ongoing measurement too. So I'll just flick to the next slide. Our technology is about really trying to reduce those cycle times. So so we provide, and you can see it in front of you, a platform for the management of soil data. We integrate with near on probably 24 labs globally. We work with most of the most of the ALS laboratories around Australia. In the US, we work with labs like Paste Labs and other agricultural soil testing labs, as well as contamination labs, to help help our clients collect and manage that data. We provide an interface to access that data too. We have the sampling layer. So this is the REMscan technology, which is a mid-infrared spectral sensor that our clients use in field, in situ, to measure total petroleum hydrocarbons. And we also help develop and build additional models for our clients to conduct measurement on. That's really cool. It's ISO certified. And we have probably 74, 75 units globally right now, from places as diverse as Antarctica with the Australian Antarctic Division, to Nigeria, to Kuwait, and the United Nations use us quite extensively for a lot of their contamination testing and cleanup. Of course, the benefit of that is cost saving. A few of the use cases, I'm not going to go into these in detail. You can read them on the website, but used a lot for contamination risk mapping. We do a lot of rehabilitation, and in particular, we call it MRV, but monitoring, reporting, and verification of these rehabilitation and environmental improvement projects. And then, of course, at the end of life mines, we do in-project. Our technology, I should say, because we're not doing it ourselves, is used by consultants and by our clients for in-project verification and compliance. So because we integrate directly with the laboratories, we provide our clients with the automated chain of custody between the ground and the lab, as well as an ISO certified device for the measurement of total petroleum hydrocarbons. So the implications, one of the more fun slides. Look, I think the key thing is we typically save between 200 and 300K per annum. Most of our clients see a return on investment within about a year. That's primarily due to the reduction in laboratory testing, because with an in-field sensor measuring TPH, you send far fewer samples back to a lab for testing. But then coupled with the spatial data capabilities, we help identify plume contaminations much faster. And we also help with the excavation of soil much more rapidly. So as you're excavating that site, we help reduce over-excavation, because our clients can conduct scans on the soil that they're continuing to excavate immediately for total petroleum hydrocarbon contamination. We see an average annual saving of between 0.9 to 3.5 mil per closure per year, which is pretty good. Turning minds into natural capital. The last 30 seconds. So a lot of our history, a lot of our background has come out of agriculture, where really the name of the game, a lot of what our clients are trying to do, and we're talking not individual farmers, mainly asset managers. So we work with most large asset managers across Australia, from Treasury Wine Estates to AACO. They're very interested in biodiversity projects, as well as soil carbon projects. One of these new topics that's coming up more and more is renewable energy, and pairing things like solar farms with grazing on that same land, which is really exciting. I'm really keen to see more of this fusion between biodiversity and productive land use, which I think is really exciting, and something we're seeing a lot more in the mining space as well. So that's it from me. Plan, sample, analyze, and report. The OODA loop of environmental measurement. If you have any questions, please put them in the chat. Thanks, Tammy.
Oh, thanks so much, Sam. And Sam had a cool video in his presentation that unfortunately we weren't able to get to work during the practice session, but we'll make sure that everyone gets a link to it in the post-webinar follow-up. All right, last but certainly not least, I'd like to introduce you to our final presenter of the webinar. Please welcome Jonathan Milne with Thiess Rehabilitation. Over to you.
Thanks, Tammy. I'm Johnny Milne, Group Manager at Thiess Rehab, and I'm pleased to have the chance to chat briefly this afternoon on post-mining transformation and some of the recent work that Thiess has been doing. So I thought I'd start briefly, for those who aren't familiar with Thiess, with how do we fit into this picture? What is Thiess, and why are we involved in this space? So in short, we are bloody fantastic at digging big holes. And we've been doing that for a long time, around 90 years, and are now the world's largest mining services provider. And as part of that journey, almost as a byproduct, over time, we've become really excellent at what comes next, post-mining transformation, rehabilitation works. And if we just take a brief look at the Australian landscape, there's around 240 mines forecast to close in the next 15 years, and around 200 in care and maintenance currently that are registered operating mines, amongst the backdrop of not one single example of complete surface mine rehabilitation and relinquishment. So there is work to be done, not as Thiess, but as an industry more broadly, that we all need to lean into. And in line with that, Thiess created a standalone rehabilitation function in 2022 to now offer services dedicated and in discrete sort of standalone fashion in post-mining transformation. Really, our core services within Thiess are engineering-led execution team. So we've got really great capabilities in some of those mine operational fields like mining engineering, geology, geotech, spatial services, environmental advisory, but we don't do everything. So there's sort of different aspects up and downstream where we look to partner and working with others similar to those presenting today on enclosure-specific sciences. But yeah, have a strong history in the mining background. Across the Thiess group, we've got MACA, PYBAR, RTL, Thiess, and in that group, there's a really diverse range of capabilities that can contribute to post-mining transformation activities. And today, I'll chat to you a little bit about one of our more recent projects at Idemitsu's Muswellbrook coal mine. So this is in the Hunter Valley, situated around 3 hours northwest of Sydney. And this mine was actually started by the Thiess brothers in 1944, the surface mine at Muswellbrook. And at the time, this was the first open-cut coal mine in the Southern Hemisphere. So it's almost poetic that some 8 decades later, Thiess had the opportunity to come in and do the post-mining transformation and rehabilitation earthworks on the site. So the scope of the project included design and construct and was run as a turnkey operation. So Thiess had statutory control and ran the project for around 3 years from start to finish. Now, as part of the services that we offered, we considered the reference design and how that could be optimized, and the engineering team, in combination with 3D data guidance team, looked at geotechnical sequencing to reduce the total material movement required on the project by around 20%. Now, that's a really significant figure when, in our experience, most of the cost, around 80% of the cost in the execution works for rehabilitation, are linked to bulk material movement. Now, this was a really interesting project to get to work with, and kind of really actually forced us to get in touch with the creative side of engineering and find the best pathway forward. So I mentioned 1944 was when the surface operation started. It was actually 1907 when Muswellbrook Coal started as a mine with the underground. We've got more than 100-year history, and as you'd expect, not all spatial records are in good shape or available for a project like that. So there's a number of areas that we went into that we were looking at design by excavation in certain instances. And yeah, often as an engineer, I'll say that we like straight lines and having a clear plan, but that's not always the case when you're working on a project like this. So that was a really fascinating aspect of the project. The post-mining land use was pasture and native ecosystems. And on this project, that involves slopes that were nearly all 25% and up to 30%. So for the Hunter region, that's quite steep. Typically, the geofluve in the area is operating around 12 to 18%. So for us around execution, that really added to some specific deliberate thinking about how we went around doing the work, managing safe truck haulage and placement of topsoil replacement materials, etc. The other key aspect of this mine and rehabilitation on this site was it was for the size of it, a relatively deep hole, so around 225 meters from the top to the bottom, and that meant really quite considered deliberate sequencing to unpack the puzzle with buttressing, water management, and staging. It's not as simple as just pushing material off the top to make a slope. It's really got to be staged carefully to make sure we do it safely. Now, I've got a before and after here to give you some sort of feeling of the type of work that was involved. Before I sort of show you the after, a quick comment on the type of work that was happening. This wasn't typical progressive mine rehab. This involved blasting to reshape high walls, load and haul to destack the eastern high wall that you can see on the right-hand side that went down, as I mentioned, 225 meters to water and silt at the base. And one thing that's clear when you're dealing with the end of a mine life against progressive rehabilitation is that not all hectares are born equal. Typical truck dumps run around 10 to 15,000 cubes a hectare. To complete rehabilitation, void shaping is quite different. And yeah, this project was around 60,000 cubes a hectare. So really quite intense on the total material movement to reach rehabilitation. So 1 million cubes of blasting, just over 7 million cubes of dozing, and around 5 million cubes of truck and shovel. So here is the project after 2.5 years. So pleased to say, and Thiess really is thrilled to have been working with Idemitsu on this, as mentioned, with statutory control, to have the project completed on time, safely, and to a high standard, and recordable injury-free for that duration. Once we completed the bulk land shaping that you can sort of see in that picture, there was also water management structures, so 19 kilometres of contours, 3.5 kilometres of drains, and around 160 hectares of seeding, growth medium, fertiliser and mulch. So as you can imagine, there's a range of processes that go from start to finish to take you from an initial post-mining landscape to the executed landform. And again, with Idemitsu, it was really important here to work on quality control and insurance. And we use in this Thiess's ITP system, which has been raised by the New South Wales government as sort of a best-in-class approach, and was really useful on this project. And we now take that to wherever we're doing this type of work. So really, that's a summary of the Muswellbrook side. And I just thought I'd take a moment whilst we're in the Hunter Valley to give a bit of context on a site next door and give you perhaps a different look. So Muswellbrook, whilst it was a large sort of circular void, was the type of rehab is linear by nature, contours and drains, and typical with much of what's happened on the East Coast for quite a while. About 3 kilometres over the other side of Muswellbrook Township, we have a brand new site. So this one's been running around 9 years as a greenfield operation that Thiess started and completed the first rehab and has now been completing the ongoing rehab, where we are doing geomorphic or geofluvial rehabilitation. Now, by nature, it's quite a scientific type of landform to design and execute, highly engineered, focus on water flow, drainage, and it's a complex landform rather than a simple landform. And to give you the feeling of that, there's a fly over here that can sort of give you some kind of a feeling of the landform shape. Now, instinctively, when you look at building something like this compared to linear landform, it's going to feel more expensive. But the reason I raise it is to probably pick up on some of the themes earlier today. With planning in advance, the type of rehab that we're completing here is certainly cheaper than what we did over the road and on par with what we do anywhere else in the country. So with good planning in advance and quality control around where you put material, you can achieve an entirely different outcome for a cheaper cost. And Tammy, that's me. So I'll just say thanks for the time this afternoon. Happy to answer any questions that come through. Thanks to Isha, Bianca, Nick, and Sam for some insightful presentations. And yeah, one closing thought: it's never too late to be proactive and sort of get towards a safe, stable, long-term solution that you can optimize when you put some work into it.
Great. Thanks so much, Johnny. Thanks for that great conversation from all of our presenters today. So that concludes the formal presentation. So now we'll move into the live Q&A. So again, you can submit your questions using the Q&A interface in Zoom. So let's just get started with some prepared questions that we have for our presenters. Let's start with Bianca. What are the most interesting post-mining land uses you've seen either investigated or applied?
Thanks, Tammy. Yeah, that's a super interesting question and one where we're seeing some real novel changes in. So we've started to see interesting research facility post-mining land uses being approved or investigated. We've seen fossicking areas that would be part of tourism as another one that's been starting to be looked at. Data centers is probably one of the most forthcoming and interesting land uses that are being explored right now, and it'll be exciting when we get to see the first data center approved in Queensland. But definitely internationally, we're seeing a lot of interest in that sort of outputs as well for land uses. So there is a real movement away from just grazing and native ecosystem and into those more interesting novel uses where they're possible.
Great. Thank you so much, Bianca. Nick, this one is for you. If you had to summarize one mindset shift that you want planners and executives to take away, what would that be?
Well, at risk of being a bit repetitive, the mindset shift is that sustainability outcomes must be designed from the beginning, right? Not necessarily produced at the end. This often means that ESG is no longer an externality, and that resilient value means robust MPV, and that survives ESG stressors, just not peak MPV. So the combination of early integration and trade-off analysis, which can be translated into smart design, catering for technical ESG aspects, a little closer to the design solution, transparency, empowerment of communities, tangible outcomes, in terms of opportunities for local businesses and things like that. So I think if you can mush it all together, that would be the mindset shift.
All right, here we have one here for Sam. How accurate is GXLab at mapping contamination across the site?
So yeah, we talk about accuracy and precision in context of two things. The spatial measurement and the MIR measurement capability. So from an MIR perspective with REMscan, REMscan's ISO certified to measure TPH in soils. It's got an R squared of about 0.97 and can detect as low as about 66 milligrams per kilo of TPH. So it's very good. It's one of the reasons it's used globally, and one of the reasons that we bought the business. Spatially, and this is where it gets interesting, because to measure and monitor plumes, it comes down to the quantity of measurements, and that ultimately comes down to the budget that you're looking at. And again, this is where having a low-cost measurement tool like an MIR spectral measurement device can be really useful in reducing the cost of lab testing and increasing the precision of particularly plume monitoring and detection. So those two things coupled together, I think the answer is very accurate, but it depends on the budget. Yeah, thanks, Tammy.
Very good, thank you. All right, and Johnny, the audience wants to know, has Thiess been involved in a post-mining transformation outside of the Hunter Valley?
Thanks, Tammy. Yes. So yeah, around 12,500 hectares completed in the last 15 years or so. And across Australia, there's a broad range. And again, looking at the TEAS group, quite a different range of applications. So if we look at PYBAR within our group, who provide underground mining services, they completed the raise bores at Kidston Underground, which is now a pumped hydro. And in the West, for example, Macca, again, a group business, complete a range of rehabilitation works. But yeah, Iron Ridge over there. Northern Territory, RTL, our group has worked on Rumjungle, which is a uranium mine site. And then through, I guess, TEAS's historical heartland in Queensland and New South Wales coal precincts. Quite a large amount of hectares in different formats there. And then just more broadly, around 6,000 hectares completed in Indonesia, and a new business starting in North America, focusing on Canada and the US to provide reclamation services for legacy mine sites.
Thanks so much, Johnny. All right, y'all, I'm afraid that is all the time that we have for questions today. If the audience submitted a question and we didn't get a chance to answer it, I'll make sure that the appropriate presenter answers that question for you offline. The final webinar as part of the Mining Innovation Across the Life Cycle series is the Reimagined Mine, which will be on Monday, the 15th of June. To register for that webinar, please visit the Austmine website. And then I would also like to bring your attention to Austmine's recently launched webinar series, Mining Operations, the Issues That Matter Now. Again, please visit the Austmine website to have a look at the topics that will be included in this series, and of course to submit your expression of interest to be a presenter, which I should note is open to Austmine members only. So I'd like to give a really big thank you to all of our presenters today. Thank you so much for sharing your time and your expertise with the audience. And then, of course, to all of our attendees, thank you for taking time out of your day to be with us. So I look forward to welcoming you to another Austmine webinar in the future, and please enjoy the rest of your day.
Thank you. Thanks, Tammy.
Guys.
Thank you.